Spark continues to be a highly popular distributed computing framework. In episode 9, we highlighted the challenges associated with Apache Spark. Nowadays, many enterprise and large data platform teams are considering or have already begun migrating their Apache Spark workload to Snowflake. In this video, we will explore what are they doing, how are they doing it, and the path they are taking for this migration. If you search online, you will find that most of the available content on Google or even on the Snowflake platform mainly focuses on conversion of Spark syntax to Snowpark syntax or PySpark to Snowpark Python code conversion. They believe that simply converting the syntax will complete the migration process. However, that's not the case. In this video, we will deep dive into why that is not enough and discuss the other important migration aspect to be considered. If you have ever dealt with a complex data platform that operates on large Hadoop cluster, you are familiar with the multitude of Hadoop core components, ecosystem tools, and various open source utilities. When it comes to migrating your computational workload from Apache Spark to Snowflake, there are several important considerations. It is not just converting your PySpark or Spark syntax to Snowpark equivalent syntax. You may wonder about the equivalent component or services available in Snowflake. Will you need to re-architect your system, or will you have to compromise on your target architecture? The Apache Spark to Snowflake migration is just one piece of the puzzle. There are broader concerns to address, and this video will assist you in assessing and establishing a path for your migration journey. If you are interested in gaining a comprehensive understanding of the migration, make sure to stay tuned until the end of this video. We will cover everything you need to know. Welcome back to my channel Data Engineering Simplified, and to this Everything About Snowpark playlist for true data professionals and data engineers like you. In this episode 11, we will deep dive into all the detail about migration path from Apache Spark to Snowflake. We have reached the second to last episode of our Snowpark awareness playlist. As you may know, this playlist consists of a total of 12 chapters. If you would like to explore a specific topic, feel free to pause the video, review the episode list from here, and jump to the specific topic that interests you most. You can find the links to all the videos in the description section below or in the info card above. These videos are recorded in 4K resolution. Follow the instruction for better resolution and to learn it faster. Before we proceed, I have a quick announcement. I have published more than 100 videos covering different topics under different playlists. And if you find it hard to get into a specific topic or a subtopic or a specific concept, use this summary card for a quick search. Summary card download instruction is given in the description below. For additional queries or specific question, feel free to drop me a note to my Instagram account. Let's quickly review the fundamental of Apache Spark project or ecosystem. When we discuss Apache Spark architecture, we encounter multiple technical components that work together within your data platform tech stack. The Spark core serves as a processing engine responsible for efficiently managing your workload. To interact with Apache core, you utilize one of its APIs such as RDD or data frame or Spark streaming or Spark SQL. These APIs allows you to write your Spark code using popular programming languages like Scala, Python, R, or Java. Once your Spark code is written in any one of these programming language, it is ready to run. In this diagram, you will notice that your Spark job requires a runtime environment to be successfully executed. In addition to the runtime environment, Spark also relies on a storage layer. This storage layer provides the data and also allow Spark program to write its data once it is successfully processed. When discussing the migration from Apache Spark to Snowpark, it is important to note that PySpark or Scala Spark code can be migrated to equivalent Snowpark Python or Scala code respectively. However, if you have written your Spark program using R, there is currently no equivalent available in Snowpark. Migrating your data storage layer will not be a challenge at all. The storage layer will be hosted by Snowflake tables post-migration. And we also don't have to worry about resource management layer. Post migration, it will be taken care by Snowflake Cloud Service Layer. However, it is essential to understand that any existing data platform architecture for any migration process can be much more complicated than what is depicted here. Let's look into typical data platform ecosystem. In a mature and a large enterprise-grade big data platform that runs a Spark job, it is important to note that these jobs are not executed in isolation. They need to be hosted within a Hadoop distribution. This distribution can vary and may be an open source option or a closed source platform like Cloudera or Hortonwork. If you have worked on a big data platform like Hadoop, you are likely familiar with different core libraries, ecosystem libraries, and tools that are integrated together. This component work in harmony to support various teams including development, testing, business users, and many other personas and stakeholders. I would like to highlight some commonly data flow pattern when considering the migration from Spark to Snowpark. The first layer is the data source layer, where we commonly encountered 6 types of data sources. RDBMS data sources like Oracle, SQL Server, or DB2. Data consumed from FTP location. Web API data, which is retrieved using REST API in most of the cases. IoT data sources, object storage platforms like S3 or ADLS Gen 2, streaming data from platform like Kafka or similar streaming services. The second layer is the data ingestion layer. Here, a platform team may have developed an ingest framework or might be using paid tools. Commonly used tools include Apache Scoop for data export and import using JDBC library, Spark Read library for reading data from JDBC, file system, or streaming platform. Additionally, utilities may be built using JDBC or ODBC libraries, Python libraries, or Kafka running KSQL to consume and ingest data from different data sources. Once data is ingested, it is typically written to the HDFS file system in a different file format. Commonly used file format include CSV, XLS, zip, Parquet, ORC, Avro, JSON, XML, and binaries. Data can also be written to Hive managed storage location in Parquet or text file format. The next layer or logical area involves performing transformation, generating curated and consumption dataset. Popular technologies used in this stage are Hive queries, Impala queries, or Spark. Within Spark, you may work with RDDs, data frames, Spark SQL, Spark Streaming, or Spark ML libraries. All these flows can be orchestrated using tools like Apache Uzi or shell scripting, Apache Airflow, or custom Python and Java utilities. And sometimes, some enterprises use third-party tools like Control-M or Rundeck. On the right-hand side of the diagram, we have analytics and BI tools. Commonly used technology stacks here include Power BI, Tableau, or custom-built web applications. Keep in mind that there are many more tech stack and tools available that we haven't touched upon in this overview. For example, how to manage single or multiple instances of a Snowflake Cloud Data Warehouse. Should it be single instance or a multiple instance, or should it be in the same region or across the region, etc. A legacy platform typically has 2 or more environments supporting your development activities, testing activities, and production workload. How my continuous integration and continuous deployment would look like. My existing CI/CD pipeline will work post-migration or not, and if not, what needs to be done. How the access control should be migrated, and what is my current architecture versus Snowflake Snowpark architecture will look like. How will I onboard my users, service accounts, analytics users, and BI accounts in Snowflake, and will it be very different from what we have been doing so far, like Active Directory integration or single sign-on integrations. How my existing data privacy will be migrated, and how will it work in Snowpark/Snowflake ecosystem post-migration. If you have a data lineage tool integrated in your existing platform, how will it work with Snowpark and Snowflake environment? Does it need a new tool, or your existing tool will work after integrating with Snowflake and Snowpark? How does your current disaster and recovery architecture will be migrated to Snowpark/Snowflake environment? Does it need a complete re-architecture, or it can use some of the Snowflake's native feature? And if so, how? Your team must be sharing data using data export utilities on FTP location, using Spark program, or using some other libraries. How that will work in future with Snowflake and Snowpark. You might have an audit and observability framework, and those frameworks might be using the log file generated by your Spark program or other utilities. How that framework will be migrated when you migrate and run your workload in Snowflake and Snowpark environment. In the context of this migration path, it is crucial to align various platform users such as Spark developers, SQL developers, QA engineers, data ops engineers, data leads and architect, and data managers. Some individuals may have concern about transitioning to Snowflake, Snowpark, fearing that it will shift their focus towards becoming more like a SQL developer and potentially hinder their competitiveness in the market. Additionally, leads and architects may worry that their Spark design and optimization skill will become irrelevant in the market due to fully managed nature of platform like Snowflake. We thoroughly discussed this topic in our previous chapters, especially in chapter 3 and chapter 9. It is important for large enterprises to consider moving towards cloud native solution. Failure to do so can result in higher operational cost and loss of cost effectiveness. Eventually, large enterprises and data platform may be compelled to transition to cloud native platform to optimize their resources and expenses, and that will also push technical folks to lean in that direction. We don't have much choice. So you make sure that your resources who are going to be part of this migration process are aligned and having the full positive intent make your migration project a successful project. If you come across a blog or a content claiming that the automation of Apache Spark to Snowflake/Snowpark migration can be achieved with the conversion rates of 70% or 80% or 90%, it is important to recognize that such claims are often exaggerated and far from reality. These claims are merely attempt to sell content rather than reflect the true nature of a migration process. Platform migration represents a significant change for any organization. It encompasses more than just technology. It also involves people, their interest, and the process that have been developed and implemented within the data platform over the years. Enterprises are actively seeking cloud data technologies that offer a wealth of features, facilitate easy and fast development, promote collaboration, prove cost effectiveness, and ensure security. That's precisely why migration to such technologies have gained immense importance. These migrations generate valuable outcome and deliver significant value to end user. By adopting these advanced cloud data technologies, enterprises can enhance their capabilities and effectively meet the evolving demand of their business operations. If you are a data platform architect who has contributed to building an Apache Spark based data processing platform, you may find yourself either fully or partially agreeing with the point we have discussed so far. Now it is time to tackle the big question: what does the migration path from Apache Spark to Snowflake/Snowpark look like? In a short video like this, it is challenging to provide a highly specific answer to this question. However, the remainder of this video will outline a path that will assist you in creating your own migration journey. With iterative steps, you can minimize and mitigate potential risk along the way. The goal is to empower you to navigate your migration process successfully. Let's use this diagram as our starting point for our discussion. Your Apache Spark environment may resemble this diagram, but it is important to note that it could have some missing component or look entirely different. However, the process of identifying the tech stack, understanding their roles within the data platform, and determining what they aim to achieve remains same. In our discussion, we will cover two different approaches. The first approach involves identifying a critical business process within your enterprise that has strict SLA agreements. We will then draw a migration path specifically for that process. The second approach is a big bang approach where the entire data platform is migrated to Snowflake Snowpark at one go. Each approach has its own advantages and disadvantages. However, the first approach is more popular as it helps mitigate technical, process, and people related risk. It also allows you and your team to learn, make corrections, and iterate the process as needed. Both approaches require meticulous planning and close monitoring to ensure a successful migration. To ensure a structured discussion, we will begin by exploring approach 1 in detail. Once we have covered all the relevant aspects of the approach 1, we will then proceed for approach 2. Now let's dive into the first step of our migration path. The first step in our migration path from Apache Spark to Snowflake Snowpark is to create an inventory of all the data sources and the data they acquire. This includes data obtained through both pull and push mechanism. In approach 1, we agreed that we would focus on a specific subject area to narrow down our effort. During this step, it is possible that you will identify two data sources related to this subject area. The first one might be a relational database system, and the second one could be your FTP location. You are pulling data from both these data sources. It is crucial to list down how they are pulling data from these data sources. Are they utilizing an in-house built ingest framework or a paid tool or Apache Scoop or a JDBC ODBC driver? Additionally, you should capture the number of tables or entities being pulled along with their volumes. Determine whether it is a full refresh or a delta load. It is also important to document the type of connectivity such as network over a VPN or something else, and security and authentication mechanism in place. All this detail should be included in your inventory. This information is vital because during the migration, it will help you to determine whether you can simply lift and shift the data or if you need to lift, re-architect and then shift it accordingly. Once the inventory list for data source is created, we can move to our next step in the migration path. From this discovery process, your inventory worksheet may look like this. Moving to the second step, it is essential to capture all the file formats utilized within your subject area or a business area. File formats hold significant importance as Snowflake Snowpark may have limitations when it comes to processing certain type of file formats. We have already covered these limitations in detail in our previous chapters, chapter 9. Understanding and documenting the file format will help you a smooth transition during your migration process. Now let's go through the list of commonly found file format in the big data platform. Approach 1 has identified several file formats. CSV file, also known as delimiter separated files, zip file, Parquet file, and JSON file. These files are typically created using your data ingestion tools or framework. To load them into your target Snowflake environment, you will need to employ a suitable method. If you are unsure about a specific data loading method, I recommend checking out my entire data loading playlist, where I have covered this topic in depth. Your inventory worksheet via step 2 may look like this. You will also add the location of your file in your Hadoop file system along with partition pattern if applicable for certain file format, and also add the compression attribute if applicable for some of the file format. Finally, we will create an inventory for our workload, including the jobs that orchestrate the workflow. These jobs are responsible for pulling data from various sources and applying transformation rules to generate curated data. Within your curation layer, you may utilize Hive queries or Impala queries or Spark program, all orchestrated through shell script or Uzi coordinator or Apache Airflow or even some custom Python or Java utilities. While capturing information about this Spark or SQL workload, it is important to note if they involve full load or incremental load process via insert override or append, the pattern followed for incremental loads, the complexity of each workload, the volume of data being operated on, and how failures are handled, whether restarting from beginning or resuming from where it failed. Additionally, capturing the processing time, dependencies between workload, data quality assurance, and audit process within your environment is crucial. Ensure that each of these items is well documented in your inventory sheet. We should also capture the downstream application that consume the curated data, integration protocol used by this downstream application, and the workload associated with analytics and BI platforms. Once you complete these steps, your inventory worksheet will extend and it will get a shape like this. Now that you have completed the inventory of all tech stack, their respective runtime environments, and their functionalities, let's move forward. In the next step, we can exclude the data sources and the tech stack component that are not utilized or not applicable for this migration scope. By doing so, we can refine the overall picture and narrow down our focus. Once we have this refined list, it becomes easier to define the migration boundary. This boundary sets the scope for our Hadoop to Snowflake Snowpark migration planning. It ensures that we have a clear understanding of a specific element that needs to be migrated, allowing us to proceed with a well-defined strategy. Moving forward on this migration path, the next step is to identify the equivalent component in our target environment, which is Snowflake Snowpark. We need to find the corresponding counterpart for each component or a functionalities that was present in Apache Spark ecosystem. This ensures a seamless transition and enable us to leverage the capabilities offered by Snowflake Snowpark effectively. It is important to note that Snowflake cannot directly connect to FTP or RDBMS systems, nor does it provide equivalent object or services like Apache Scoop or JDBC ODBC libraries. In order to ingest data into Snowflake, you have a couple of options. You can either develop your own ingest approach or route the data through object storage platforms like S3 or ADLS Gen 2. Alternatively, you can use paid tools such as Fivetran. Designing an effective and secure data ingestion process is crucial. This assessment step is a key because without a reliable and timely data transfer to the landing layer in Snowflake, the migration process cannot progress further. Ensuring secure and efficient data movement is a vital for success of your migration to Snowflake. Snowflake is continuously adding new features and connectors to its platform. It is highly possible that the challenges we have encountered so far might have a straightforward solution in future. So continue to check Snowflake feature list and reassess your migration approach for such limitations. Now let's shift our focus to the file format. Snowflake has capabilities to process 6 different file formats. However, it is important to note that zip files are not supported. This means you need to rethink and possibly redesign your processing approach for zip files. There are a couple of options available to address this. First, you can perform the necessary processing before data lands into a Snowflake layer. This can be achieved by utilizing a cloud runtime environment. Alternatively, you can explore Snowpark's new file API, which allows for pre-processing of these files before consumption. However, it is crucial to carefully plan and design your approach before moving forward. Additionally, it is important to ensure that you validate the JSON files and Parquet custom data types. Snowflake imposes a limitation of 16 MB per field, as we discussed in our JSON playlist. If you are not familiar with these concepts, I recommend reviewing my JSON playlist to gain better understanding. With these steps, your inventory sheet will get better shape, and that will help you to reassess your migration risk on technical ground. Lastly, you will review your workload inventory. This involves examining the number of Hive and Impala SQL queries present in your legacy platform. Migrating Hive queries and Impala queries is generally straightforward, except for the functions that are specific to either Impala or Hive. Next, you will focus on your Spark program. For each workload, you need to analyze its purpose and determine which Spark API is being used. This could be read-write API, RDD API, data frame APIs, Spark SQL APIs, streaming APIs, or various ML libraries and APIs. Based on this assessment, you can determine whether it can be migrated to Snowpark. If it can, you will need to consider the appropriate approach. If it cannot be migrated, you will need to explore workaround and design alternative solution to fulfill those requirements. Additionally, we need to consider whether we want to use tasks and stored procedures to orchestrate our jobs, or if we prefer a more mature solutions like dbt. It is worth considering dbt as Snowflake ecosystem does not have exact replica of Uzi or Apache Airflow. Undoubtedly, this migration path building process involves a significant amount of work. Depending upon the size of your data platform, it may take approximately 6 to 8 weeks or even longer to complete. It is important to note that there are many other aspects we haven't touched upon yet. These include coding guidelines, best practices, role-based access control migration, continuous integration and continuous deployment approach, security measures, data masking, governance, and many more. Each of these aspects require careful consideration and planning during your migration path development process. If you choose approach 2, where the entire platform is considered, your inventory may appear extensive. This is because there are numerous tech stack components involved. However, the overall process remains same regardless of size and complexity of the platform. Approach 1 offers several key advantages. By narrowing down the scope of migration to a single subject or a business area, the data platform team can gain valuable insight and learning before tackling other business processes and workload. Approach 1 enables faster discovery as it allows for easier collaboration with resources from a single business unit, as opposed to coordinating with multiple teams across department. It facilitates the learning of common components that are utilized across various business domains and workload within the data platform. Since many data workload within a platform share common component, it becomes easier to evaluate and address any incompatibilities or challenges during the migration planning phase rather than encountering them in a big bang approach. This approach also helps gauge the sentiment of individuals involved, allowing for an assessment of team competencies and adaptability to Snowflake technology. Overall, approach 1 provides a structured and focused approach that enables effective learning, collaboration, and mitigation of risk during the migration journey. In certain scenarios, Big Bang approach for migration may be preferable, and there can be various reasons for this. If you are decommissioning your existing legacy platform and have a fixed deadline, it may not be feasible to iterate and migrate gradually. If each subject area follows its own unique pattern and there is no commonality between them, running them one after another may not yield the desirable result. If your platform is not well organized and has a monolithic architecture, it may be more efficient to migrate all at once. These are just a few examples, but there could be other reasons as well. However, the inventory creation process and technical risk assessment that we discussed for approach 1 will need to be repeated for each subject area in the Big Bang approach. This ensures that you have a comprehensive understanding of the requirement and challenges specific to each area, enabling a smoother migration process. Here are the 4 high-level steps in the migration process. Step 1, discovery and inventory creation. In this step, we explore how data is acquired and processed, allowing us to understand the workload volume and estimate it accurately. Step 2, assessment and technical risk mitigation. Building upon the information gathered in step 1, we evaluate and assess the technical aspect. This involves identifying what can be migrated directly and determine alternative design approach for the rest. Step 3, automation possibilities. Once the technical assessment is completed, we consider whether any automation tool are available to aid in the migration process. There are several tools that can help migrate SQL queries and Snowpark program. Step 4, migration execution. Based on the workload volume, technical assessment, and chosen approach, manual or automated, we proceed with the migration activity. This includes one-time data loading, incremental data loading job design, cutoff planning, parallel run planning, and ensuring auditability and observability. This provides a high-level overview of the migration path. If you are interested to know API level differences and commonalities, I would request you to watch chapter 2 from this playlist. To understand more about competencies, learning path, and who should learn Snowpark, chapter 3 provides in-depth coverage. On chapter 8, you can also explore Snowpark's deployment model within and outside of the Snowflake. If you would like to see how a Snowpark program looks and how it can be used, there is an end-to-end use case episode and playlist available for your reference. Additionally, you can watch Snowpark learning playlist which explain various Snowpark API and their usage. And if you and your team wants to learn in more organized manner, you can refer my curated playlist that are available free of cost in this channel. I am sure you have gained a new perspective of Apache Spark to Snowpark migration. It goes beyond simply converting PySpark Python code to Snowpark Python API code, as most blogs and articles tend to focus on. Please feel free to share your migration challenges by leaving a comment in the comment box below. You can also reach out to me through my Instagram account Thanks for watching episode 11. And yes, if you have made the decision to migrate your legacy Spark code to Snowpark, you may be wondering whether the Scala API or the Python API for Snowpark is a better choice. In that case, I highly request watching my next and final chapter, chapter 12. If you have learned something valuable from this episode, don't forget to press on the like button and share with other data engineers and Snowflake developers. Happy learning and keep growing.